Hello and welcome to this lesson on animations in Android. In this lesson, we'll take a look at several different methods and tools for adding animations to our Android applications. Android provides a variety of powerful APIs for applying animations to UI elements and drawing custom 2D and 3D graphics. The Android framework provides two animation systems: Property Animation, which was introduced in Android 3.0, and View Animation. Both animation systems are viable options, but the property animation system in general is the preferred method to use because it is more flexible and offers more features. In addition to these two systems, you can utilize drawable animations, which allows you to load drawable resources and display them one frame after another. We will cover both of these systems shortly. When writing an application, it's important to consider exactly what your graphical demands will be. Varying graphical tasks are best accomplished with varying techniques. For example, graphics and animations for a rather static application should be implemented much differently than graphics and animations for an interactive game. When creating graphics and animations for an interactive game or more interactive application, there are a few options for drawing graphics in Android. Android provides a set of view widgets that provide general functionality for a wide array of user interfaces. You can also extend these widgets to modify the way they look or behave. In addition, you can do your own custom 2D rendering using the various drawing methods contained in the Canvas class, or create drawable objects for things such as texture, buttons, or frame-by-frame animations. We will cover these techniques in depth in a future lesson. Android also supports some versions of OpenGL ES, depending on the version of Android and other hardware requirements present on the device. In Android, we can easily perform a series of simple transformations. For example, alpha animations, which change the transparency of an object, rotation-related rotation animations, size-related scale animations, or position-related translate animations on the contents of a view object. So if we have a text view object, we can move, rotate, grow, or shrink the text very easily. If it has a background image, the background image will be transformed along with the text. The animation package provides all the classes used in these animations and includes the classes like alpha animation, rotate animation, scale animation, and translate animation. A sequence of animation instructions defines these animations and can be defined by either XML or Android Java code. As with defining a layout, an XML file is recommended because it's more readable, reusable, and swappable than hard coding the animation in Java code. In the upcoming example, we will see an example of an XML animation. The animation instructions define the transformations that you want to occur, when they will occur, and how long they should take to apply. Transformations can be sequential or simultaneous. For example, you can have the contents of a text view move from left to right and then rotate 180 degrees, or you can have the text move and rotate simultaneously. Each transformation takes a set of parameters specific for that transformation, things like starting size and ending size for size changes, or starting angle and ending angle for rotation, and so on. They also receive a set of common parameters, for instance the start time and duration of the animation. To make several transformations happen simultaneously, give them the same start time. To make them sequential, calculate the start time plus the duration of the preceding transformation. Here we have an example of an animation written in XML format. The animation XML file belongs in the res.anim directory of your Android project in the resources directory. The file must have a single root element. This will be either a single alpha, scale, translate, rotate, interpolator element, or a set element that holds a group of these elements together. The following XML is from one of the API demos from the Android code samples, and the file name will be defined as hyperspace jump XML. It is used to stretch, then simultaneously spin and rotate a view object. The first scale animation will scale the x from 1 factor to 1.4 factor, and the y from 1 factor to 0.6 factor. And it will also pivot the x and y by 50%. The fill after parameter, when set to true, will apply the animation transformation after the animation is over. We then follow with the combination scale and rotate animation, which will begin after the first scale animation is completed. This is denoted by the start offset parameter for the following animation definition, which is set to 700, which is the duration of the first scale animation. Once this animation is defined in the res anim folder in the resources directory, it can be set to a view in Android. Here in the Java aspect of this example, we grab an image view in the normal fashion from our UI. We can then obtain an animation by calling the load animation static method on the animation utils class, with the parameters of the context and an integer for the resource ID for that animation, which is the XML which we have just previously declared as hyperspace jump XML in the animation resources file. We can then start the animation on our image view by calling the view method start animation and passing it the given animation that we have obtained from our resources. A drawable animation lets you load a series of drawable resources, one after another, to create an animation. This is a traditional animation in the sense that it is created with a sequence of different images, played in order like a roll of film. The animation drawable class is the basis for these drawable animations. While you can define the frames of an animation in your code using the animation drawable class API, it is much simpler to define them in a single XML file that lists the frames that compose the animation. The XML file for this kind of animation belongs in the res drawable directory of your Android project. In this case, the instructions are the order and duration for each frame of the animation. Here is an example of a drawable animation XML constituted by an animation list in the XML. This XML code, which is saved to the file rocket_thrust_xml in the res drawable folder, and then can be set as the background to a view or can be started in Java code, as we see in the Java aspect of this example. We grab our image view and we set the background resource to the rocket_thrust_xml that we have defined. We then grab the animation drawable from the image view by calling getBackground. On a touch event, we can start the animation drawable by calling the start method. Property animations were added to Android in Android 3.0 API 11. The property animation system is a robust framework that allows to animate almost anything. You can define an animation to change any object property over time, regardless of whether it draws to the screen or not. The property animation system lets you define the following characteristics of an animation. The duration. You can specify the duration of an animation. The default length is 300 milliseconds. Time interpolation. You can specify how the values for the property are calculated as a function of the animation's current elapsed time. Repeat count and behavior. You can specify whether or not to have an animation repeat when it reaches the end of a duration, and how many times to repeat the animation. You can also specify whether you want the animation to play back in reverse. Setting it to reverse plays the animation forwards, then backwards repeatedly, until the number of repeats is reached. Animator sets. You can group animations into logical sets that play together or sequentially or after specified delays. Frame refresh delay. You can specify how often to refresh frames of your animation. The default is set to refresh every 10 milliseconds, but the speed in which your application can refresh frames is ultimately dependent on how busy the system is overall and how fast the system can service the underlying timers. The value animator keeps track of an animation's timing, such as how long the animation has been running and the current value of the property that is animating. The value animator encapsulates a time interpolator, which defines animation interpolation, and a time evaluator, which defines how to calculate values for the property being animated. The view animation system provides the capability to only animate view objects, so if you want to animate non-view objects, you have to implement your own code to do so. The view animation system is also constrained in the fact that it only exposes a few aspects of the view object to animate, such as the scaling and rotation of a view, but not the background color, for instance. Here we have some examples of how to use property animations in Android code. The value animator class lets you animate values of some type for the duration of an animation by specifying a set of int, float, or color values to animate through. You obtain a value animator by calling one of its factory methods, of int, of float, or of object. As we see in this first example, the value animator starts calculating the value of the animation between 0 and 1 for a duration of 100 milliseconds when the start method runs. In the second example, the value animator starts calculating the values of the animation between start property value and end property value using the logic supplied by myTypeEvaluator for a duration of 100 milliseconds when the start method runs. Finally, in the third example, we see how we can animate the property of a view object, such as the rotation of the view, by calling the offFloat method with the parameters of the view, rotation, and from and to values. Android includes support for high-performance 2D and 3D graphics with the Open Graphics Library OpenGL, specifically the OpenGL ES API. OpenGL is a cross-platform graphics API that specifies a standard software interface for 3D graphics processing hardware. OpenGL ES is a flavor of the OpenGL specification intended for embedded devices. Android supports several versions of the OpenGL ES API. OpenGL ES 1.0 and 1.1. This API specification is supported by Android 1.0 and higher. OpenGL ES 2.0. This API specification is supported by Android 2.2, API level 8 and higher. OpenGL ES 3.0. This API specification is supported by Android 4.3, API level 18 and higher. And OpenGL ES 3.1. This API specification is supported by Android 5.0, API level 21 and higher. Please note that support of the OpenGL ES 3.0 API on a device requires an implementation of this graphics pipeline provided by the device manufacturer. A device running Android 4.3 or higher may not support the OpenGL ES 3.0 API. The specific API provided by the Android framework is similar to the J2ME JSR 239 OpenGL ES API, but is not identical. If you are familiar with J2ME JSR 239 specification, be alert for variations. Android supports OpenGL both through its Framework API and the Native Development Kit, or NDK. There are two foundational classes in Android Framework that let you create and manipulate graphics with the OpenGL ES API. They are the GL Surface View and GL Surface View Renderer. The GL Surface View class is a view where you can draw and manipulate objects using OpenGL API calls, and is similar in function to a surface view. You can use this class by creating an instance of GL Surface View and adding your renderer to it. The GL Surface View Renderer interface defines the methods required for drawing graphics in a GL Surface View. You must provide an implementation of this interface as a separate class and attach it to your GL Surface View instance using GL Surface View setRenderer. Thank you for joining us in this lesson on animations in Android. Join us in our next lesson where we'll take a look at custom views and the canvas in Android development.